All right, so I'm a new faculty in BME, and today I just wanted to go over with you kind of what my lab is focusing on. And so in my lab, as we're in the neural section, we focus on neural tissue engineering. So I'm interested in building and bridging new connections within the nervous system, particularly following an injury. So when we think of injuries to the nervous system, they can come in a couple of different ways. You have peripheral nerve injuries, so kind of more your sensory and your motor neurons, as well as the central nervous system, so your brain and your spinal cord. And if we take all these together, it accounts for over several 100,000 injuries sustained each year. And that's on top of the injuries that people are already living with every single day. And this results in lifetime paralysis. So to me, I like to kind of reframe it a little bit and think of it as a quality of life issue and a life-threatening issue, right? So quality of life issue are those neurons that are going to your muscles and they're impacting your ability to get around. And whereas if you think a bit more large scale, you also have neurons that are going in your spinal cord to your major organs. So if you have a spinal cord injury, let's say, and it's affecting your neurons that are going to your heart or your blood vessels or your lymphatic system, you're going to have a lot of complications which can be life-threatening down the road. So this is really kind of a long-term goal to try to address these issues. So in my lab, we use a variety of methods in order to try to rebuild these structures and connect the neurons that have essentially been severed. So one of the primary ways that my lab does this is through the development of new biomaterials. So how can we bridge one end of that nerve to the other end in order to try to regrow the tissue? Additionally, we look at how these materials are affecting the neurons in a culture. But we're not just interested in neurons, right? So in your central nervous system in particular, there's a variety of cells that are present. So we're also interested in the support cells. So if you have a spinal cord injury, your vasculature is also going to be damaged. So we need to take this into account when we're building new materials. And once we finally have some materials that we're confident in, we begin to test these in animals. And in particular, my lab uses genetically engineered mouse models because we can tell exactly which types of neurons and nerve tracts we're restoring. But more importantly, and a little bit more near and dear to my heart, are neural stem cells. So how can we repopulate the tissue in order to rebuild what we've lost, as well as using various gene therapies. So trying to bring this all together to develop a more robust solution to nerve injury and hopefully restore some of the lost function and limit paralysis in the population. So with that, that's it.